Hi guys, so today we're going to talk about Punnett squares. But here's the first thing. You need to have notes. So go get a piece of paper and a pen or pencil if you haven't already. Now I would expect that because you knew that you were going to be learning valuable information in this video, that you came prepared with paper and pencil. But if you didn't already, go get some. Really, go get some. All right, I've given you long enough. If you need longer, pause the video and then come back. All right, so we're going to talk about Punnett squares. You need to take notes because I'm going to look for them in class. So this is your last chance to not be a lazy bum. All right, Punnett squares. So the purpose of using a Punnett square is to predict the probability of a certain genetic outcome. Okay, the whole idea here is you are making a prediction and you are figuring out what's probably going to happen. Not what's definitely going to happen, but what's probably going to happen. So you're saying if this parent and this parent have a baby, what is their baby probably going to look like? What are the odds that such and such is going to happen? What are the odds that such and such is going to happen? Okay, that's what a Punnett square is for. What Punnett squares do not tell you, is it creepy that I'm moving myself around all over the place here? What Punnett squares do not tell you is what that outcome will be definitely. You cannot figure out what it's definitely going to be. You can only figure out what it will probably be. So a Punnett square will only help you with what's probably going to happen. All right, so how do we make a Punnett square? Actually, wait, first, let me give you some notes tips. If I were you, I would have a piece of paper where I have written the title and where I have written these two pieces of information, these nuggets of golden information. And look, I do. Here are my notes. Look at my title and notice that I put down the purpose of Punnett squares and I put down what they don't do because that's important too. Okay, so what I want you to do now is take your piece of paper and I want you to draw a line straight down the middle. If you're one of those people who really like straight lines, you can get out a ruler and you can use a ruler to make a straight line. Or if you just, want to freehand it, go ahead and freehand it. I'm feeling jazzy, so I'm going to freehand it. Okay, so I'm going to divide my paper in half like this. So that I've got a line going down the middle. And on the left side, I'm going to write step. And on the right side, I'm going to write example. So I'm going to do side-by-side notes. Here's the step, and here's the example, so that I know step by step what I need to be doing. Maybe PowerPoint will let me go. Okay, so here's my problem. So I'm going to start by writing down my problem. Axial flower position is dominant to terminal flower position. Okay, so I'm going to write that down. Axial flower position. I'm going to stop this video for a second because there's no reason for you to sit here while I write this down. Okay, so you can see that I wrote down my problem and I kind of abbreviated a little bit. I didn't write down word for word. I just put down what I needed because these are notes, so I don't need actual exact specific things. All right, so now I'm going to move on and I'm going to do the steps. So step one is I need to determine the letters I should be using for the alleles. So underneath steps, I'm going to write down determine, and I'm doing this underneath where I wrote that example. Determine the alleles. Oops, sorry. Determine the letters to use for alleles. Okay, so here's step one. Oop, wrong way. Okay, and notice that I wrote that in the step area. Okay, in the step area, determine the letters to use for the alleles. So what are my alleles going to be? Well, I know that axial is dominant to terminal, so I'm going to use letter A's. Axial flower position is dominant to terminal, so a big A is going to be axial, and a little a is going to be terminal. So over in the example side, I wrote big A is axial, little a is terminal. Okay, so now I can go to the next step. Step two. Wow, this is really annoying, isn't it? Determine the parent's genotype. So I'm going to leave myself a little room, and then I'm going to go down and write in the steps, determine parents' genotypes. Okay, so now I need to take a look at what I know about the parents. Well, first of all, they told me we have a parent, let's see if this corner's better. We have a parent plant that is heterozygous for flower position. Heterozygous for flower position means that we have big A, little a, because it's heterozygous. Heterozygous means different. So I'm going to write down big A, little a. And then I have a plant that is homozygous dominant. So I'm going to write down big A, big A. And I'm going to decide that I am going to cross them. So I'm going to put an X in there. So again, in my example, I've got that I have a heterozygous parent and a homozygous dominant parent, and I wrote that they're crossed because this one is what I would be doing if I were showing my work on a problem. These are the steps, this way. These are the steps that I would be thinking in my head, but these are the steps that I would be showing on my paper. So my cross is big A, little a with big A, big A. Step 3, I'm going to draw a Punnett square. And a Punnett square is just a square with a crisscross in the middle. So now I'm going to draw my Punnett square. So I wrote down my step and I drew my Punnett square. Okay. Now I need to arrange the parents' genotypes on the square. Okay, so step 4 is arrange the parents' genotypes. This is where we're going to use Mendel's principle of segregation. So we're actually going to segregate our alleles. So we have our first parent who was big A, little a. That's the first parent. They're going to go across the top. So I'm going to make myself a little sub-step in my steps here. And I'm going to write first parent across the top. Okay, so my first parent was big A, little a. But remember that the parent can only send one of those alleles, okay? Cannot send both of them. So only one of those alleles can go up on top of a box. So we've got the big A here, and we have the little a here. Then the second parent's genes are going to go down the side, one gene next to each row. So I'm going to write down second parent down the side. Okay, now what I'm going to do in my notes is I'm actually going to make a second Punnett square so that really I'm seeing step by step by step. So this is a little tedious for the note taking, but it's going to make our notes awesome. All right, and I'm actually going to use some color. So I'm going to make the first parent orange. So I'm going to do a big A and a little a in orange. And I'm going to use pink for my second parent. And so I'm going to use big A there. And I'll show you what my paper looks like. This is what my paper looks like. Now notice that I went up to the top and I circled, and I circled my two parents in the colors that I used then down on the bottom. So my colors are matching, so I know what's going to happen here. Okay, so my next rule, so that's what my parents look like. So now I'm going to fill in the square. So I need to go over to the back of my page here, so I'm going to make a new heading that says step, a new heading that says example, so that I remember what's what. I'm going to put a line down the center. Step 5 is fill in the square. Fill in the square. Okay, well that sounds like it's probably more complicated because that doesn't quite seem obvious right now. So what I'm going to do is pull the first parent's genes down. So I'm going to write down as a little sub-step, pull first parent's genes down. Okay, so I'm going to remake my Punnett square now, especially since I'm on the back. And I'm going to remake it the way I made it before. So I'm basically just redoing those steps. This seems tedious, but it's really good practice for you. And it's practice in a good, safe environment where you're going to be able to check all of your answers. So when I pull the first parent's genes down, what that means is I'm going to take this big letter A, and I'm going to move it down into this box, and then I'm also going to move it down into this box. I'm going to take this little letter A, and I'm going to move it down into this box, and I'm going to move it down into this box. So there's the big letter A, there's the little letter A. Then the next step is I'm going to pull the second parent's genes across each row. Okay, so I'm going to write down pull second parent's genes across. So that means that this big A right here, I'm going to pull across this way. And this big A right here, I'm going to pull across this way. So that big A goes across, and that big A goes across. So now I'm going to do that on my notes sheet. And it's going to be really pretty and colorful in my notes sheet, just like it is on the screen. Now what you'll notice is that over here, we have little a, big A. We know that's really supposed to be big A, little a, right? So we can fix that later when we do our actual work on, when we do our actual answer that you're going to put a box around as your final answer if you're doing a quiz or something. Okay, so step 6 is where we're going to list our potential offspring. Okay, so list potential genotypes. That means we're going to figure out what genotypes are possible. And we do that by looking inside the box. The inside of the box shows us our children. So we have 4 possible children here. Our 4 possible children are going to be big A, that's this person. Big A for this person. Big A for this person. Okay, now notice I flipped it around when I wrote it over here. Or big A for this person. So I've listed my possible genotypes. So I'm going to go back to my notes. Big A, big A, big A, big A, big A, little a, big A, little a. Okay, so have I shown you my pretty notes yet on this side? Ooh, look how pretty those are. Okay. So what I really have then, if I condense that down, is that I have 2 big A, and I have 2 big A, little a, assuming we have 4 kids. Now, mind you, they might only have 1 kid. They might have 16 kids. Who knows what they're going to have? They might have 4 kids or 5 kids or 12 kids. We're just figuring out a probability, so that's okay. All right. What that means then, what it breaks down to, is 50% of our kids are going to be big A, and 50% of our kids are going to be big A, little a. So when we write our answer, we could write this in percentages, where we're going to write 50% big A, and 50% little a. Or I might ask you for something like a ratio. I think I have a ratio here, maybe not. So a way that we could write this as a ratio is 1 to 1, because we have the same numbers. We have 2 and 2. We reduce that down to 1 to 1. So 1 to 1, big A, to big A, little a. Okay, 1 to 1, big A to big A, little a. Because we have to say here what we're comparing when we do our 1 to 1. We need to say what we're comparing so that people know what it is. Now notice we don't have any little a here. Aw, nobody's going to have terminal flowers. That's just the way it is. That's just the way these parents are. They're not going to get any babies with terminal flowers. Just all axial. Okay, but we'll do that in the next step. So here are my notes. Look, lots of notes. Whoa, can you see that? Is it? Oh, there they are. Okay, there are my notes. Notice there's a lot for that step. Now, you're not always going to do all of that. Just sometimes. It depends on what the question is asking you for. And usually the question will ask you for something specific. Okay, but there's my final answer. So step 7 is we're going to list the possible phenotypes. So I'm going to write that down. List possible phenotypes of my offspring. So again, I know I have big A, big A, big A, big A, big A, little a, big A, little a. All of those are going to be axial because they all have big A's. Big A always means axial. Everybody's got a big A, everybody's axial. So we could say axial times 4. We could say 100% axial, or we could say 1 to 0 axial to terminal. All of those are ways that we could say this. I don't think I need to show you my notes for this. I think you probably have it by now. I think you can do this step by yourself. That's what you're going to do. That's how you do a Punnett square. These steps are going to be super duper useful to you for later on predicting the probability of an offspring. So if I say to you, what's the probability that this plant is going to have, that these 2 plants are going to have baby plants with axial flowers, you can say it's 100% probability. All their babies are going to have axial flowers. You can do this with all kinds of different things, and you're going to get to do a lot of practice like that when you come to class. All right, hopefully you did a great job of taking notes. I will see you in class.